Okay, we got some practice problems here on limits, and just about all of these. I think you know by now that to evaluate limits, you can just plug in that x value that's underneath the limit symbol. But you know, we're not going to give you continuous functions. We're going to give you functions that have either asymptotes or holes or jumps or something wrong with them. So if you look in letter A here, if you do plug in 2, you'll get 0 over 0, which is an indeterminate form, which means you have to do some kind of algebra. And for most of these rational functions, just do some good old-fashioned factoring. The denominator looks easier. Each term has an x. If I factor out x, I'm left with x minus 2. The numerator is a trinomial, so I'm going to try to factor as two binomials. X squared is x times x. And to multiply to 6 but subtract to 4, I would do 2 times 6. And to get myself a plus 4 in the middle, I would go plus 6 minus 2. And guess what? I'm luckier than a cat with two tails because the 0 over 0 part canceled out. That's what was holding you back. So now you can go ahead, evaluate your limit. In other words, let x become 2. And if I do that, I got 2 plus 6 over 2. Which is 8 over 2, that's 4. Bada bing, bada boom, I got my limit. I can move on to number B, letter B, I should say. Don't forget, I'm going to go kind of fast here because these are problems I've gone over in previous videos, but hit the pause button if you think I'm going too fast. Letter B, same deal here. If I plug in, I would get an indeterminate form. That goes for all of these, so I got to do a little bit of factoring. So let's give it a shot. So I want to still do the limit, right? I keep bringing that symbol down until I don't have to anymore. Up top, I can factor out an x, right? If I take out an x, I'm left with x cubed minus 8. In the denominator, I can take out x to the second. If I'm left there, I'm left with x minus 2. And oh my Lord, look what we're up top. We got a difference of cubes. That's not good. So we can keep going here. So I can do the limit as x approaches 2. Actually, these x's, one of them will cancel, right? So I can kind of knock that guy out with one of these. Still left with x, right? So let's take care of those x's. So we're left with just the x. Now I got to do that x cubed minus 8. I'll do that in pink so as not to confuse anybody. Again, it's cube root of each and then square the first term, square the last term, and then multiply the 2 and the negative x and change the sign in the middle. That's factoring cubes. That's from Algebra 2, although it's, we kind of tend to forget about how to factor cubes. And lo and behold, I got a common factor of x minus 2 top and bottom. So I got to knock those guys out. So at the end of all of this, finally, I can evaluate my limit, right? After I do all my factoring and canceling, I can let x become 2. So up top, I have 2 squared plus 2 times 2 plus 4 all over 2. If I add that up, I get 12 over 2, so that's 6. There's my limit. Again, this is kind of the beginning, end of pre-calc, beginning of calculus, and the hard work is Algebra 2. It's all factoring. All right, let's look at a couple more. Here's one with a radical. It's a kind of a rational function with a radical up top, and the trick there is to multiply by the conjugate top and bottom. So I'm going to do that right here in the first step. So I'm going to multiply by square root of x plus 5 plus 3. I got to do that top and bottom, right? And if I multiply that out, let's see what happens. Again, I still have the limit as x approaches 4. Up top should get a lot nicer, right? These first two terms give me an x plus 5. The back end minus 3 and 3 is minus 9. And the bottom, my suggestion, do not multiply it out. Leave it factored because you want to do some canceling. Right? Again, a lot of steps, but that's just kind of the way things go sometimes. Up top, I got x minus 4. Here I got 4 minus x. And I'm just really copying down what I have. In fact, I'm going to give myself a little bit of room. This is called cheating right here. Make that a little smaller to give myself some room. And I can do some canceling, right? I got x minus 4 and 4 minus x. Those are negatives of one another, so they do cancel out to -1. And then finally, I can evaluate my limit. So let's do it. Let's let x become 4. So up top, I still have -1. On the bottom, I have root 4 plus 5 plus 3. Be careful, that plus 3 is not, it's not in the radicand. And so I got -1 over root 9 plus 3. That's -1 over 6. There we go. And D, finally, I have a limit at infinity. If you remember, the trick there is look to the denominator and divide by the highest power. So what am I doing? Up top and bottom, I'm dividing by x to the 4th, right? Divide the bottom by x to the 4th. And so here we go, limit x at infinity. And remember, that's the trick at infinity, right? Nowhere else you do that. If I divide by x to the 4th, I get 3 over x. If I divide 10 by x to the 4th, I have 10 over x to the 4th. X to the 4th divided by x to the 4th is 1. Middle term, I get 10 over x squared. Here I got 1 over x to the 4th. And don't forget your limit theorems. If the top is constant and if the bottom has an x, at infinity, all these become 0. So I'll just do this little arrow, 0 out, 0, 0. That becomes 0. So what happens up top? When you actually evaluate this limit, the top becomes 0 minus 0. The bottom becomes 1 minus 0. Minus another 0. 0 over 1 is, of course, 0. And if you don't want to prove this stuff like I just did, maybe you can just look at the leading coefficients or leading terms. If the bottom has a higher degree, fraction gets closer and closer to 0 at infinity, or horizontal asymptote at 0. Okay, that was the first video. We're going to have a couple more videos to get through this problem set.